So we're going to talk about the congruence theorems we've learned so far. We've learned 3. There are 5 total. So congruence theorems. What was the very first one we learned? Side, angle, side. Remember, we are educated folk, so we don't say SAS, we say side, angle, side. Where did the angle have to be in comparison to the sides? Included or between. Okay, so you would have a side, an angle, and a side. It's basically what you're looking for. What was the flipped classroom about? Side, side, side. So what did that one basically say? Yeah, all the sides are congruent to all the sides. That makes sense. And then you also learned about... Nope. Hypotenuse leg. We're talking about theorems that are theorems. Hypotenuse leg, when does it only work? In what kind of triangle? In a right triangle. Okay. This should actually be your first question when you see a right triangle. So if you have a right triangle, you should ask, is it hypotenuse leg? Okay. Because it most likely is. Today we're learning 2 new ones. They're the title of your page. So what do we think the new ones are called? Angle, side, angle. Where do you think the side is in comparison to the angles? In between. So you're going to learn that. You'll have an angle, a side, and an angle, basically. This one, to me, reminds me of a football. Like the center of a football has all the laces. So you'll have an angle, side, and angle. It'll be on one side of the triangle completely. You'll learn about that in a minute. And then the other one is called what? Angle, angle, side. This is also known as side, angle, angle. Both are acceptable to me. When we're looking at diagrams, what were the 2 things that we could draw into the diagram? One of them was vertical angles and the shared wall. So vertical angles are congruent. A shared wall, or you could say, what word did I use? Overlapping side, I think, is congruent. So that meant if you have a triangle and another triangle, the side they share is congruent to itself. So that's it. These are the 5 theorems you'll use. So notice which ones are not theorems. These are the ones that are memorable for most people. So what did I say would never be a theorem? So not a theorem. Yeah, so side, side, angle. Okay, definitely not a theorem. And then another one that's not a theorem is angle, angle, angle. Not a theorem either. AAA. Those are not theorems. And I'll explain why angle, angle, angle is not a theorem today. Okay? You, I'm pretty sure on your quiz, actually have to list the theorems. So make sure you know them. Side, angle, side, 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 hypotenuse leg, angle, side, angle, 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 side. Okay? So I'm going to move to the next screen, if that's all right with you. We're going to decide if the 2 triangles are congruent. So we're going to have a yes or a no. And then, if so, list the theorem. In number 1, what kind of triangle are both the triangles? Right triangles. So whenever you have a right triangle, you need to ask yourself, is this hypotenuse leg? So where's the hypotenuse in comparison to the right angle? It's on the other side, right? Is my hypotenuse marked congruent to my hypotenuse? It is not. So is this hypotenuse leg? No. So we can move on and try the other theorems. I'm going to compare my triangle on the left to the triangle on the right. I have a side marked congruent to a side. What else do I have? The angle, because it's 90 and 90, which is congruent. And then what else do I have? A side. Is this a theorem? Yes, it is. So, yes, they're congruent because of what theorem? Side, angle, side theorem. Good. Let's go ahead and write that in. So the answer, yes, because side, angle, side theorem. Yes, you need to write theorem. Number 2, I'm going to compare my triangle on the left to the triangle on the right. I have a side marked congruent to a side. What else do I have? Another side, congruent to another side, and then another side, congruent to another side. Is this a theorem? Yes, it is. Which one? We don't say SSS because we're educated. Side, side, side. theorem. It actually doesn't save you time to say SSS, because how many syllables is side? 1. And then how many syllables is S? 1. Same thing. There's actually a bridge in New York called the George Washington Bridge. Y'all ever heard of it? It's how you get from New Jersey to New York. You cross the bridge. Anyways, George Washington Bridge is 5 syllables. They try to shorten it to GWB. It's the same amount of syllables. It's dumb. Anyways, here we're going to say side, side, side theorem. Same amount. Number 3. What do we think? We have a side. We're going to do a side. What else do we have? An angle, and a side, and a side. So, yep, we do have side, angle, side theorem. What do we notice about number 4? We have a right triangle. So we should ask ourselves, is this hypotenuse leg? Are the hypotenuses marked congruent? Yeah. They are, says my hypotenuse. Is a corresponding leg marked congruent? Yes. So is this hypotenuse leg? Yes. So they're congruent by hypotenuse leg. Number 5, going to compare my triangles. So I have an angle marked congruent to an angle. What else do I have? Side to a side, and then angle to an angle. So we haven't learned this theorem yet. Is this one of the ones we just listed? It is. Which one is it? Angle, side, angle. So you haven't learned it yet. We're going to learn it today. But it is angle, side, angle theorem. You have 2 angles and then an included side. And then number 6, what do we think? You just tell me the answer. Side, angle, side. Good. So yes, side, angle, side theorem. Go ahead and flip to the next page. So this is where we break down the 2 theorems we're learning today. Can I help you, ladies? Do you want to read it to the whole class? So we're going to prove triangle congruence by angle, side, angle, and angle, angle, side. The first one is angle, side, angle. You're going to see that you have a blank at the top of your page. This is where you fill in the angle, side, angle congruence theorem. You don't have to fill in the blank, but I am going to have you underline some things or box some things. If you have 2 angles and an included side, so the important part is that you have an included side. What did included mean to us again? Between. So if you have 2 angles and a side in between them, marked congruent to 2 angles and a side between them, then the 2 triangles are congruent. Okay, so angle, side, angle. If you notice, all of the information, again, is on one side of the triangle. Your angle, your side, your angle. All right? Make sure you fill in what the name of the theorem is. So, if we're filling in the blank, what is angle A congruent to? Angle D. AC is congruent to? DF. Angle C is congruent to? Angle F. These are all fill in the blanks. Triangle ABC is congruent to? Triangle DEF. All right, so we're going to do our first example. We have in the diagram, AB, what does the symbol mean? Is perpendicular. So AB and AD intersect and form 90. Did we already know that in the picture? We did. It also says, what is it? DE is perpendicular to AD. So again, they intersect and they form 90. We knew that too. And then the last it says AC, which is this line, is congruent to DC, which is this line. We're proving the triangles are congruent. So let's see what we have. We're going to compare one triangle to the other. We have a right angle. Is this angle congruent to another angle on the other triangle? It is. So angle A is congruent to angle D. What else do we have? Side AC is congruent to DC. And then what else do we have? We have one more thing.
Angle C is congruent to angle C.
Yep, but we're not going to call it angle C. But you're correct. You're in the right direction. So these two are vertical, so they're also congruent. So here's what we're going to do. We're going to name them using angle, side, angle. So the first angle we said was angle A was congruent to angle D. Then we named some sides. What side in the first triangle did we mark? AC was congruent to side DC. Oops. Nobody caught that?
I saw it.
My bad. It is what it is. All right, and then the last one, I'm going to pause so that we can name an angle, because this class spent 20 minutes on naming an angle last week. Yes, we did. We're naming these two angles. I'm going to name this one first. Why can I not name it angle C? Yeah, there's actually 4 angles at C. So there's this one, there's top one, there's this one, there's 4 angles. So you want to name this specific angle. What letter has to be in the direct center? C. So I could say, what 2 options? ACB, or I could say BCA. Layla, which one would you like to use? ACB. So ACB. The second angle, if I said ACB, what letter has to come first? D, and then C, and then E. D, C, E. This proves the 2 triangles are congruent by the angle, side, angle theorem. That's it. All right, angle, side, angle theorem. We learned one more theorem. It is the angle, angle, side theorem. So this is the blank at the top of your page. Angle, side, angle, angle, side congruence theorem. So Nate, we're on the next page now. And we're filling in a blank. Angle, angle, side theorem. So what you're going to box in the definition, you have 2 angles and a non-included side. So go ahead and box that in. A non-included side. What do you think non-included means? Non in between, okay? If 2 angles and a non-included side of one triangle are congruent to 2 angles, and the corresponding, go ahead and underline that or box it in, corresponding non-included side of a second triangle, then the 2 triangles are congruent. So fill in the blank, and then I'll explain why it says corresponding in a second. If angle A is congruent to angle what? Angle D. So angle A and angle D. Angle C and angle F. And then we're going to name sides. So what side on the first one? BC would be congruent to EF. If this is the case, we have angle, angle, side. That is enough to prove triangle ABC is congruent to triangle DEF. Let's do this. Nah. Nope. Let's do this. Okay. So here's what it means by corresponding. It looks like we have an angle. This is my example. It looks like we have an angle marked congruent to an angle congruent to an angle. And then we have a side. Do these 2 correspond together? Are they in the same spot on each triangle? No, so this would not be angle, angle, side because they're not in the same spot. Does that make sense? That's what it means by corresponding. If you look at ours, BC and EF are in the same spot on the triangle. Okay? Our first example, you don't have this drawn, so you need to draw it. You have all the words written, you just don't have the drawing. So go ahead and draw your two obtuse triangles. And then fill in all the information. Yes. No. You clicked. It's right there. See how all these words match these words? All right, so let's compare our triangles. What do we have in the first triangle marked congruent in the second triangle? We have an angle marked congruent to an angle. What else do we have? Another angle congruent to another angle. And then we have a side congruent to a side. So first, we need to decide if this is angle, side, angle, or angle, angle, side. Angle, angle, side. And the reason being is that the side is not between the two angles. So the side would have to be marked congruent here, but it's not. So we're going to do the angle, angle, side. This is our proof. Angle, angle, side. So what was the first angle we marked congruent? Angle A congruent to angle D. The next side we marked congruent. C and F. And then the side we marked congruent. Sure. If we said CB, then we would say FE.
Did you say BC?
Yeah, you can. But if you said BC, you would have to say EF. So this is our proof. That's it. We're almost done. You officially learned almost everything in this chapter. You have one lesson left. We're just going to refine some things. Before we do these problems, I know they did not print out perfect. So you're going to reinforce what's already there. So I didn't put this information in there. It's in the picture. You just can't see it in the black and white, so I would mark it. So go through and make sure your pictures match mine. All of those arcs and the lines and things, they matter. So if you don't see them on your picture, you need to add them. We ready? So in letter A, we're going to compare the triangle on the left to the triangle on the right. What do we have marked in both of them? An angle. What else do we have marked in both of them? Side. So at first glance, it appears we don't have enough information. But what else are we missing? The vertical angle, congruent to the vertical angle. So which theorem is this? Angle, angle, side. So it says, can the triangles be proven congruent? That's a yes. And then, if so, state the theorem. So we're saying angle, angle, side theorem. That's it. Letter B. What are the only things we have marked congruent? Angles. Are there any sides that are congruent? No. Is angle, angle, angle a theorem?
No.
It is not. These are not congruent. I'll tell you why they're not congruent. I'll use the most basic example. If you had an equiangular triangle, what is the measure of all the angles? 60. If it's equiangular, what else is it? Equilateral, right? So if all an equiangular triangle, so let's pretend that this is a perfect equiangular triangle, right? So that means all of these sides would be congruent to each other. Okay, we following? In our second, if it was equiangular, it's still equilateral. So all of these sides would be equal to each other. Are these two triangles congruent? Are they the same exact triangle twice?
No.
No, but are all the angles congruent?
Yes.
Yes. So angle, triple A is never a theorem because there's only so many ways for three angles to add up to 180 degrees. Does that make sense? So angle, just not a theorem. Okay? The last one, we're going to compare the triangle on the left. What do we have congruent? We have an angle. What else do we have? An angle. And then what else do we have? A side. So, yes, they're congruent, but by which theorem? Angle, side, angle theorem. Good. Mine's just going to pop up a bunch of words. We've already written this down. And then this is the last one. State if the two triangles are congruent. If they are, state how you know. So doing the same exact thing. What do we think about the first? What do we have congruent? An angle and an angle. What else do we have? The side, which one? The middle one, the one they share. So which theorem would this be? Angle, side, angle. So it'd be yes, because it's angle, side, angle theorem. So again, look, all the information is on one side of the triangle. Number 2, what do we have congruent? We have an angle, we have another angle, and then we have the side. So which theorem would this be? Angle, side, angle. Number 3, what do we have congruent? We have a side, we have an angle, he's right. What else do we have? An angle, which one? Yeah, the vertical angles are congruent. So, is this a theorem? Yes, it is. Which one? Sure, side angle, angle, which is the same thing as angle, angle, side. Both are acceptable. They're the same thing. Number 4, we have a side congruent to a side, and a side congruent to a side. Do we have any other information? No. Is there a theorem that goes over this? No. So this would be not congruent. It's just not enough information.